Hi everyone, my name is Sean Moriarty, and I'm going to show you how to train a neural network in 5 minutes with Elixir and Axon. Now for this tutorial, I'll be using Livebook. Livebook is a platform for writing interactive code notebooks in Elixir. If you're coming from the Python ecosystem, it's very similar to Jupyter Notebooks. I highly recommend you follow the link in the description to the Livebook website, and then follow the installation instructions for your machine before getting started. It'll just make it a lot easier for you to follow along and not have to write this in an Elixir script. Now, without further ado, let's hop into the code. Now, the first thing we're going to need to do is install some dependencies. Obviously, for this, we're going to need Axon and current version 0.5, NX, current version 0.5, EXLA for actually accelerating the training of the neural network, and that current version is 0.5. We'll need SciData, which is a library of curated data sets in Elixir, and that current version is 0.1. And then we'll also need Kino for doing some things that interact directly with Livebook. We're going to specify 0.0.0 or anything greater than or equal to 0.0.0, and that'll just let the Elixir dependency management choose which version is compatible with all the other libraries in here. Now I'm going to reconnect and set up and let this run. Now before we can actually go about creating and training our neural network, we need to actually prepare the data for training. For this tutorial, we're going to be using the MNIST dataset, which is a collection of 60,000 handwritten digits from 0 to 9. Each image is 28 by 28 and grayscale. If you don't fully understand what that means, you'll have a better idea as we move throughout this tutorial. MNIST is kind of the hello world of machine learning, so this is kind of the perfect neural network for you to train on. The first thing we're going to do is actually download the dataset, and we can do that using SciData, so I'm going to call scidata.mnist.download. And if I run this here, you'll notice what I get back is a tuple of tuples. Each tuple, images and labels, represents the actual data right here, which is a binary, the type, and the shape. Now you'll notice we have the shape for the images is 60,000 because we have 60,000 images, and then 1, which represents a single color channel or grayscale, and then 28 and 28, which are the height and width of each image. If you look at the labels, you can see we have the binary data, we have the type, which is an unsigned 8-bit integer, and then we have 60,000 because there are 60,000 labels. And you can actually see that each label maps directly to a handwritten digit. So here I have 5, which would mean that this first image example represents a 5, 0 means 0, 4 means 4, and so on and so forth. Now the next thing I want to do is I want to convert these images and labels into tensors. So to do that, first I can match on the actual raw representation, which is the data, shape, and type. And then I can take the data and convert that into a flat tensor using nx.fromBinary. And that takes the binary and the type. And finally, I want to reshape this into a tensor that is the same shape as what I got from SciData. So if I run this, you'll see I get a tensor that is 60,001 by 28 by 28. And you can realize what each of these individual entries represents by actually taking a look inside. So I'm going to grab the first tensor in this collection of 60,000, and then I'm going to convert it to a heat map. And so we can get a visual representation of what each one of these tensors actually represents. Now you see here I get a heat map, and that is the handwritten digit 5. And if you go up here, notice I have the label 5 here that corresponds to each one of these. Now, the next thing I'm going to want to do is I'm going to want to take these images and I'm going to want to actually normalize them. Normalization is just a process of squeezing our data into a common scale. In this case, I want to squeeze each of those tensors between 0 and 1, and that's just going to help us train our neural network just a little bit better. So I'm going to do that by dividing by 255 because the maximum value for each one of these cells in the tensor, or each one of those rows in the tensor, is 255. And finally, the next thing I'm going to want to do is I'm going to want to actually flatten each one of those images, which right now they are 1 by 28 by 28, as you can see here, into a single vector. And I'm going to do that by calling nx.reshape again, 60,000, which is the actual number of images in the data set, and then I can just specify auto here, which gives me a nice little vector. And I'm going to assign that to this variable here, images tensor. Now if I run this, you'll notice I get a tensor here, which is float 32, 60,000 by 784. Now the next thing I'm going to want to do is I'm going to want to actually convert my labels into a tensor as well. I'm going to do that by first matching the same way that I did, equals labels, and then I'm going to call labels data, nx.fromBinary again, and I'm going to go ahead and I'm going to reshape that as well. Now if I run this, you'll notice I get this tensor here, which is 60,000. And in order to actually get this to work with Axon's training API, I'm going to want to go ahead and add a new axis to the end, and that's just so Axon knows has the proper shape that it expects. Now, if I reevaluate that, I have a tensor here, which is 60,000 by 1, where each one of these entries represents the label, and I have my image tensor here as well, and I should be good to go. Okay, so before we can move on, I realized I forgot to assign this to a tensor, so I'm going to go ahead and do that real quick, and I get my tensor out. Sweet. So now we're ready to actually create our model. We're going to do this using the Axon Model Creation API. We're just going to create a simple feed-forward neural network, and you'll be able to visualize what that actually means in just a little bit. So the first thing I have to do is specify an input, and I'm going to give it the name of features. You can name it whatever you'd like, doesn't really matter. And I'm also going to give it a shape, which is just a little hint to let Axon know the shape that it represents. This nil right here just represents a dimension that you don't necessarily know the exact shape of. In this case, this is the batch size, so I could give it batches of 1, batches of 2, which just means 1 tensor at a time or 2 tensors at a time. Now, the next thing I'm going to do is I'm going to pass this into a dense layer. And this dense layer is going to have 128 units, and that's really just the width or the number of outputs that I want this layer to have. Now I'm going to pass that to an axon.relu activation. Then I'm going to pass that to another dense layer. In this case, I want this to have a width of 10 because I want to have 10 outputs from this neural network. And those 10 outputs map each to one of the labels from 0 to 9 that we have up here. Then finally, I'm going to apply a softmax activation here. Now, if I run this, you'll notice I get a nice little summary of my model. I have 5 nodes, 1, 2, 3, 4, 5. I have my input features here, and then that's the shape that I specified right there. And this name right here, this output name, is automatically generated. So we can go ahead and just save that or change that to labels right there. Now you'll notice that output changes. So the next thing I'm going to want to do is I'm going to visualize this model just to make it a little bit more concrete what's going on here. And I can do that using axon.display.asGraph. Now I have to give that my model, and I have to go ahead and I have to give that an input template. The input template takes in a shape and a type. Now if I run this and let that render, you can see how this information is flowing forward, hence the name feed forward, and you can see how each one of the shapes transforms from layer to layer. So I have an input 1, 784, passed to a dense layer, which then gets output 1, 128, then relu, which just applies an activation function to it, and then another dense layer, and then a softmax. And that's really all there is to it. That's all it takes to create your first model. Now with my data and my model almost ready to train, it's time to actually implement the training loop. The first thing I want to do is I want to convert my data into batches. So I can do that by calling nx.toBatched on my images tensor. And I'm going to specify batch size of 32, and then my labels tensor. And if you run this, you'll notice I get a stream. Now Axon expects each of its inputs to a supervised training loop to be tuples, where the first element in the tuple represents the data, and the second element in the tuple represents the labels. So I can convert that into something that Axon is going to understand by calling stream.zip on my images and my labels. Now to verify that this is working correctly, I can call enum.take on my train data. And you'll notice I get these 2 tensors here, 32 by 784 and 32 by 1. Now, the next thing I want to do is I want to actually convert my labels to a one-hot encoded representation of each label. A one-hot encoded representation is just a sparse representation where each column represents whether or not that column index is activated. So you'll notice what that looks like when I run this in a second. The first thing I'm going to do is I'm going to call enum.map. I'm going to take each batch, and I'm going to take the images tensor and the labels tensor, and I'm going to return a tuple. Images tensor stays the same, and I'm going to call nx.equal on the labels tensor and nx.iota. And this is just a clever little trick here to actually transform the labels tensor into a one-hot encoded representation. Now if I run this, you'll see I get these tensors here, 32 by 784, 32 by 10. And that's pretty much all I need now to do to the data. Now the next thing I'm going to do is I'm going to create a supervised training loop using Axon. In order to create a supervised training loop, the first thing I need is the model. And then I can call axon.loop.trainer. And I need a loss function, in this case categorical cross entropy. And I need an optimizer, in this case Atom. And then I can just call axon.loop.run. And that'll be called on the training data. with an initial state, which in this case is just empty. That means Axon is going to take care of everything for us. And then I specify my compiler, which is going to be EXLA, and I want to train for 5 epochs. Now I'm going to want to assign this to a value trained model state, and that's going to output the actual trained model parameters. So after this is done, this variable is going to equal the trained model parameters. Now if I call run, and I'm going to let that run, your model has finished training, and you'll have this output here where you have loss for each epoch, the number of batches it ran through, and then you actually have this trained model state, which represents the parameters that your model converged on at the end of training. Now, the next thing I want to do is I want to actually evaluate how my model did. So in order to do that, I'm going to actually download a test set from SciData, and I'm going to run this. And you'll notice that I actually have something that is identical to what I got the training images for. So I'm going to go ahead and I'm going to copy the code I have up here to convert my test images and labels into test tensors and labels. I'm going to run this, and you'll notice I have 10,000 and not 60,000, so I need to change that there. Run that, and I get a tensor. And then I'm going to do the same thing for labels. Now, if I copy this, and I'm going to want to hot encode the labels ahead of time, so I'm going to call nx.equal and nx.iota. And you'll notice I have my output here. Now, the next thing I need to do is I need to actually create a supervised evaluation loop. Axon has conveniences to evaluate models in the same way that the training loop works. So the first thing I have to do is I actually have to convert these models to streams, images test data, nx.toBatched on my images tensor, the batch size of 32, and my labels test data. And that's going to get a labels tensor 32. Now if I zip this, you will notice I get exactly what I'm looking for. Zip. Okay, now I need to create my supervised evaluation loop with the model by calling axon.loop.evaluator, and then I can pass that to axon.loop.run with my test data. And in this case, I actually do need to pass an initial state because I'm evaluating the trained model with the trained model parameters, in this case, trained model state. And then I can pass my compiler, EXLA. And before I can run this evaluation loop, I actually need to tell Axon what I'm evaluating the model against. So in this case, I need to give it a metric, which is going to be accuracy, which tells Axon to evaluate the accuracy of my model on this test data right here. Now, if I run this, I get my accuracy out, and you'll notice we train our model to an accuracy of 97.1%. All there is to it. This is how you train your first neural network in 5 minutes with Axon and Elixir.